Chapter 24, Example 1. One indicator of physical fitness is resting pulse rate. 10 men volunteered to test an exercise device, advertised on television by using it 3 times a week for 20 minutes. Their resting pulse rates, in beats per minute, were measured before the test began, and then again after 6 weeks. Results are shown in the table. Is there evidence that this kind of exercise can reduce resting pulse rates? How much? So we're going to do a test and then a confidence interval for the how much. Let mu d be the difference in pulse rates after using the device. So we're doing the after column minus the before column. Our null hypothesis will be that mu d equals 0, or there is no difference in the pulse rates. The alternative will be mu d is less than 0, or the pulse rates afterwards are less than they were before on average. So let's check our conditions. First, we'll look at the normal probability plot. Looks pretty good, pretty linear. There might be an outlier there at about -4, but that's not a huge deal. The results are paired, and the sample can reasonably be considered representative. The normal probability plot fits a line. There is an outlier, but it is not influential. They're at -4, you have that 1 point below the line a bit, but it's not influential because of where it's located. The conditions are met. I will use a student's t-model for a paired t-test. Now let's go to the calculator to find our statistics, the p-value, the t-score, degrees of freedom, all of those things. So I have the data in there already. We have a before and after column. Since we're doing the difference, we're going to use the calculator to find that. I don't have to do it manually. I'll type a formula in. If you notice, I have a difference column. I'm highlighted in that box with the equal sign. I'm going to type a formula in there. I'm going to do after minus before. To do this, I simply type in the name of the columns I want. So I'm going to type in after minus before. Okay, it automatically fills all that data in for us. It did after minus before for each row automatically. So now we're ready to do some calculations with this. First, let's go ahead and look at how we found that normal probability plot. So I'm going to do a data and statistics page, just adding a new page. There's all my data. I'm going to change my x variable to the difference. Then we just right click, control menu, normal probability plot. And there is the normal probability plot we just looked at a moment ago. Now let's do our t-test. So I'm going to do a new calculator page. I'll do menu, statistics, stat tests, and we're going to do a t-test. We're not doing a 2 sample, just a regular t-test because it's paired. So mu will be 0. Our list was difference. It was the name of the column we're using. And we're going to do UD is less than 0. There's all of our statistics. T is negative 3.5. The p-value is 0.003362. 9 degrees of freedom. Our mean is actually negative 2.8. Now we'll just enter that in. N equaled 10. That was our sample size. Sigma is 2.52. X bar, our mean, was negative 2.8. So on average, the heart rate drops about 2.8 beats per minute. Our t value is negative 3.5. We had 10 minus 1, or 9 degrees of freedom, and a p-value of 0.0034. Let's check the graph of the normal model real quick. So I have a mean of 0. My t value is negative 3.5, so I'm going to shade to the left as it's a one-tailed test. The p-value of 0.034 is low, and I will reject the null hypothesis. There is evidence that this exercise device can reduce resting pulse rates. Since we rejected the null hypothesis, we like to look at a confidence interval. The question also asks us how much of a difference is there. So we're going to calculate a 95% confidence interval. My 95% confidence interval is negative 4.6097 to negative 0.9903. I am 95% confident the exercise device decreases resting pulse rates between 0.99 to 4.61 beats per minute. Explain what type 1 error would be here in context. Type 1 error would be that I rejected the null hypothesis, but it was true. In context, I determine the exercise device does decrease resting pulse rates when it actually does not. This could potentially leave the company open to false advertising claims.